Hey everyone, it's Harrison. Okay, so today I'm going to show you a project I've been working on, but I do want to note before I go into what this is not a project I did on my own. This is a collaboration via the school that I go to. I'm not going to name the school for now, just to try and keep that private, and also I don't want to involve anybody in that team that I'm working with in case they don't want to be in this video, so I'm not going to name anybody. But this is a BattleBot. Now, you've probably seen the BattleBot show. If you haven't, I'll put an image up right now.
You can tell how much respect these two champions have for one another, but so far it's been Jameson Go and Sawblaze who've been in control. Oh! Endgame gets underneath Sawblaze, pops it.
Okay. So, this is very similar, except this is a 3-pound. So there's actually a couple versions. The BattleBots that you see, I believe it's the 250 pounds. I might be wrong. But there's also 30-pound. I'm not sure what other ones there are. I think there's like 15-pound maybe. I'm not sure. But this is 3-pound. So what that means is, when I weigh this robot on like a scale, it has to be 3 pounds or less. There is like some exceptions, like for instance, if you don't use wheels and you use like some sort of way that it like shuffles, like with legs, it can go a little bit higher, but my team and I decided not to do that because it's very hard to do, and this is our first time actually making a BattleBot, so we decided to go with something simple-ish. So the tool right here that I'm using, if you don't know it, sorry, it's kind of hard to rotate. It's called SolidWorks. And if you're wondering why it's called Apex Predator, that's just the name of the robot that we decided to go with. But yeah, so it's really hard to kind of show without it like being at weird angles, so I'll just try. Okay, I think if I do this, there you go. Okay, so this is like a little bit weirder, but you can still see everything. So this is the robot. Oh, okay, I didn't realize that's how that works. But yeah, so this is what it looks like, and then this is like a side view, this is a front view, this is a top view. Yeah. But, yeah, so this is SolidWorks. So what SolidWorks is it's a 3D modeling tool. You may have heard about this. One thing that's important to note is we are not 3D printing all of this. So for those of you who don't know, when you 3D model, there's two things that you do. Either you 3D model for something that you're going to use a 3D printer to print out, and if you don't know what a 3D printer is, basically you have a model, you send it to the printer, and kind of like how a normal printer uses like the Word document that you had to print out all the words on a page, this uses that model to print out like an actual object. So for instance, the things being 3D printed here is this part right here, and then these walls, and some other stuff. And I'll explain that in a second, but the other 3D modeling type is just where you just see if everything fits together. So for instance, if I zoom in here, you'll see that there are bolts, and there are, like, this is a bearing. I know it's kind of hard to see, but yeah. So it's not just for 3D modeling, it's also to see if your parts just fit together and to get a visual representation of what your thing looks like. Because, for instance, if I go back to this, ignore this panel over here, but imagine if you just saw a drawing of this, just these three. It would be kind of hard to imagine what this looks like, right? Like, you could visually try and turn this in your head, but if you had a drawing like this, you could probably understand. But being able to turn it around and like look at the bottom and see what's here and all this stuff, it makes it really, really useful as an engineer to when you're designing stuff. So you don't have to use SolidWorks. There's a lot of 3D modeling, but SolidWorks and I believe Fusion 360, don't quote me, I might be wrong, are like the industry standards. I know for sure SolidWorks is. I think Fusion is a little bit not as used, at least in where I am. I might be wrong about that. But I know like in my university, apparently we have to take a class on SolidWorks. I haven't taken that class yet, but I've heard that. So that shows it must be an industry standard. If I'm wrong, I'll put that up on the screen. Okay, so I'm just gonna explain what this is. Like I said, it's kind of hard to do without a weird angle. So first thing you notice is the chassis, and the chassis is just a fancy word for the body. So that would be like this wall here, the bottom here. And then it's not here, but there's also supposed to be like a top plate that's made of like a clear plastic. I think it's called plexi plastic, or oh no, I think it's acrylic. But yeah. Another thing though is this robot's not finished. This is just the furthest we've gotten. So the important things to note here are the wheels, these 3 motors, this thing which is just called a Peter bar. I'll explain in a second. These are just towers that just hold the Peter bar here. And then, like I said earlier, so this is the chassis. So we went through a couple designs. I'll put a few on the screen. So the first design was the spinner. It was a lot bigger before, but we made it smaller so it wouldn't hit the motor and other things, and that's why we cut out a hole here. So yeah, so it spins this way, and the whole point is that it will chip off other pieces of the robot. And then right here, I want you to imagine where my mouse just drew. There's like a wedge almost. It kind of looks like 2 prongs of a fork, right? But just on each side. And so the whole point is, once we have those installed, is if there's another robot and this robot right here rams into it, the other robot will scoot up a little bit, and then this will rotate. Sorry, I was getting a call. This will rotate upwards, and it will chip them, but it will also lift them into the air.
One, two, three, fight! Victory!
Because remember, these robots are only 3 pounds. If I can, I'll show a video right now of just some of the robots just getting absolutely demolished.
Kick down into the loser's bracket.
Fight, robot.
They just flip over and over and over. Now, just for your information, the competition that I'm doing is just within my school. The one I'm probably showing you is probably like the nationals or the state or something like that. But yeah. So you might notice that this motor here is actually spinning when I spin this, and I can spin this one too, and it should work. Yeah. So I use the pulley tool in SolidWorks, which I don't really need to get into the details, but it just makes you have a pulley. Let me see if I can actually show you. Oh wait, I think it was right there. Or I guess it's belt, not pulley, but these are the pulley. This is a belt. So where this blue line is, there would be a belt. And basically, when this motor spins, it spins this pulley part right here as well. So when it spins backwards, this will also spin backwards because they're connected, right? But that's the whole point of that. Similar here, there's no pulley tool here, but if I zoom in here, you'll see that this little bit, if I go over, it highlights it, it says motor, and that is related to this right here. I think if I make this transparent, you should be able to see it. Yeah. So you can see how it's sticking out of there. And so basically this little bit will connect to this, and then this is in here. So yeah. So this is the robot. I don't know what I just did. Oh, okay. I just made it transparent again. Okay, I don't know why it's making it transparent and untransparent like several times. I must just be a little bit silly. Okay. I might do a SolidWorks tutorial at some point, but probably not. There's literally millions of videos online that you can find. I just recently started using SolidWorks myself. I've used other 3D modeling software, but not SolidWorks. But I decided to switch over since professional grade and stuff. So the hardest thing in here to actually make is the Peter bar. Don't get me wrong, the chassis is not like easy per se to make. I'm not the one who actually made the chassis. I made the Peter bar, but the Peter bar. What I did is I used a reference online, and if I can, I'll show the image. And I made the Peter bar. So it's made of a couple parts. First thing to note is there's an axle here, and this is a dead axle, and all that means is that when this spins, I know that it's showing that the axle is spinning. That's just because of how SolidWorks works, but this will actually stay still, and this stays still because of tolerance. So basically, this here, let me make this transparent. Oh, I didn't realize it would actually make the separate part. Okay. So if you see here, it's kind of hard to see, but this like hole right here, it should be about the same size as this shoulder bolt, and all a shoulder bolt is just it's like a screw, except that the central part of it is like smooth. So you can see like the screw ends right here, and that part's smooth. But yeah, and basically what tolerance is, let's say that I have a hole like this one right here where this shoulder bolt is, or shoulder screw or whatever, and I want to put the cylinder into a cylindrical hole. If both holes are 1/2 inch in diameter or whatever, they won't actually go into each other because they're the exact same size. But if I make the hole 1/2 inch plus, like the number I've been using is 0.005, it makes it just ever so slightly bigger than, like, for instance, the shoulder bolt part that I want to stick into it. And so they will actually slip into each other, and then there's a lot of like surface area touching each other, so there's a lot of friction. And it's just like if I make my hand this big and I put my finger in and I squeeze it, it's not the hole that I'm making with my hand isn't actually the same size as my finger. It's my finger plus like just a tiny bit more. So that's basically what you're doing, and your finger doesn't come out because it's like it's squeezing it, right? So that's the best way I can think to explain it. But yeah, so I just wanted to show you guys this, and just FYI, I might show you guys this later. I might even show you guys when we're at the competition. That's not for a few months, but yeah, this is basically what our design will look kind of like. My next job that we decided is I'm gonna get all the electronics and I'm gonna stick them in here, figure out how we're actually gonna arrange all of these, because there's not really a lot of room in here. But yeah. Okay, well that's all for this video. If you have any questions, leave a comment below. I just wanted to show you guys this really cool project. Okay, see you all.